So we can do limits using limit laws as well. So some of the limit laws allows us to split up these limits. So for example, this one here, as x approaches 1, as x approaches 1, we're going to end up with sine 0 over sine 0. Well, we know sine 0 over 0 is equal to 1. So we can split this up from the log x. So we can say the limit as x approaches 1 of sine x minus 1 over x minus 1. And we can do that limit separately from the log limit. Okay, so the limit as x goes to 1 of log x. Okay, so this is going to be equal to 0 times the limit of log x as x approaches 1. If you remember what the log graph looks like, it's going to hit the x-axis at x equals 1. So that's going to be equal to 0. So we end up with 0. Sorry, this is going to be not 0. This is the limit as x approaches 1 is going to be sine x over x, which is 1. And so we're going to end up with 1 times 0. And so that's going to be giving us a limit of 0. And we can do the same thing here. As x approaches 0 here, well, this is going to give us, we can do this, the limit as x approaches 0 of sine x minus 1 over x minus 1. Okay, we can evaluate this limit. We can actually just plug in. This is going to be sine of negative 1 over negative 1 times the limit as x approaches 0 of log x. Okay, so this is just going to end up being sine negative 1 over negative 1. But this one here is going to end up being going to 0, so it's heading down to negative infinity. So this is going to end up being negative infinity. So negative infinity times anything is going to be negative infinity. We just have to be aware of the sign here. A sine of negative 1 is going to be negative over negative. So I'm just going to do that over here. This is going to be a negative number divided by a negative number times negative infinity. So that's going to end up being negative infinity. Okay, so this is going to end up being our limit. We just have to be a little bit careful with the signs here to make sure that this actually works out. Okay, because sine of negative 1 is in quadrant 4, and quadrant 4 is a negative sign value. Okay, moving on to this one here, we can do the limit here. So we can just apply the limit to the base. Okay, so we're going to do this limit as x goes to 0 of sine x over x. Okay, and I'm just going to pull this down a little bit to give myself a little bit more space to work. Okay, and then this is going to be limit as x goes to 0 of just x. So we end up with 1 as our base, 0 as our power. Okay, well, anything to base 1 is 1, anything to power 0 is 1. So we're going to end up with a limit of 1. So this one here is actually is quite complicated. It's, well, no, I shouldn't say complicated, but it's a little bit tricky because what's going on here? We end up with x going to infinity. So what's happening with inside this 1 over x? If x goes to infinity, this essentially becomes sine 0 over 0. Ooh, well, we can work that out. We know what that is. And then we can do the exponent separately. Okay, just like we did here. So we'll do that again. And this will kind of help us out with this. So it's limit as x goes to infinity. And this is going to be sine 1 over x over 1 over x. And I'll let the limit as x goes to infinity of just the x. Okay? So we're going to end up with, as x goes to infinity, this is sine 0 over 0, and we know that's going to be equal to 1. And as x goes to infinity, we can let the exponent equal to 0, or sort of equal to infinity. And 1 to the power infinity, that's going to be a limit of 1. Okay, we probably want to check this though, because this is, some pretty tricky stuff. So we probably want to check what this graph looks like afterwards. Okay, so let's just do this last one. So we can use limits to help us draw graphs as well. So these different limit statements tell us something about the graph. So as x goes to negative infinity, we can see that f of x goes to 1. Well, what does that mean? That means that we have on the negative side a horizontal asymptote at 1. As x approaches negative 3, we're going to have a value of 2. Okay, so it looks like that. Maybe I'll just color code this so that we can kind of see where these pieces are coming from. Okay, so as x approaches 3, negative 3, we're going to have a value of 2. Okay, but the actual coordinate is going to be down here. Okay, but we know that it's approaching from both sides. Okay, so we know that it's going to flow through that point. At negative 2, as x approaches negative 2, we're going to have a value of 3. Okay, so I'm going to just do maybe this one in green. And as we approach 2 from both sides, we're going to hit a value of 3. And it's going to go through that point like that. Okay, and it looks like at negative 2, there's no point that exists there. All right, so then we move on to the local max. There's the local max at 0, 4. Okay, so there's going to be a local max there. That's a coordinate that's defined, and we know that's a maximum. So I'm just going to put a little maximum curve there. And I know that as we approach 1 from the negative side, it's going to go down to negative infinity. Oh, that's a vertical asymptote. Okay, and just checking here, as it approaches 1 from the positive side, it goes to positive infinity. So that indicates to me that there's a vertical asymptote at 1. Okay, and it looks like it's going to go down on this side, and it's going to go up on this side. Okay, so let's move on. X equals 2, y equals 0. Okay, so that point's going to be here. So I've got a coordinate right there. So that line's got to pass through that point. And then we have a local minimum at 4, negative 1. So 4 over negative 1, that looks like it's a local minimum. So I'm going to put a little curl like that. Okay, and lastly, and this looks like a horizontal asymptote, as we approach infinity, we're going to have a horizontal asymptote at 0. So kind of putting this all together then, okay, my graph looks like it's going to follow the asymptote like this, go through those points. It's going to have a max here, goes down to the vertical asymptote. Okay, it's going to go through this point here. It's going to go through the local min, and then it's going to go along the x-axis like that. Okay, so I'm just going to get rid of that there. Okay, we'll just draw that a little bit better. Okay, so we figured that little section out from that. Okay, and again, I'm just going to clean up this vertical asymptote here. So there it is. There's our graph. We have that extra point there. Okay, all the details of what we've been given here kind of have been highlighted on this graph.